Having used my calculator, here's where I found the intersection. Now the intersection, we can tell, is the point 0, is the point 27. This equation is my y1, and this equation is my y2. We want the y1 equation to be greater than or equal to the y2. So when is the y1 above y2? Well, it's above it here. And that happens, it's equal to it when x equals 20, and it's greater than that to the right. So my solution here would be x is greater than or equal to 20. That's how I would read the graph and get the solution. Now let's do that same inequality and solve it algebraically. First thing we would do is multiply by the common denominator. For 2 and 4, my common denominator will be 4. Remember, it has to be the big one or something bigger. 2 goes into 4 twice, so I take 2 times 1 is 2x minus, be sure to take the 4 times the 3 is 12, greater than or equal, 1/4 times 4 will be 1x, plus 2 times 4 will be 8. I'll subtract an x from both sides and get 1x, add a 12 to both sides, is greater than or equal to 20. Same answer I had before. We can also have a second method for using our graphing calculator to solve inequalities with the x-intercept method. First, we rewrite the inequality with all non-zero terms on one side of the inequality, I prefer the left side, and combine like terms so that we have our function less than 0, greater than 0, less than or equal to 0, or greater than or equal to 0. We graph the non-zero side of this inequality and in a window that makes the x-intercept be seen clearly. Find the x-intercept of the graph to find the solution to the equation f of x equals 0. We can find the exact solution algebraically and use the graph to determine where the inequality is satisfied. Let's see how that works. When the temperature is 100 degrees Fahrenheit, the apparent temperature, A, or the heat index, depends on the humidity, H, expressed as a decimal, according to the heat index equals 90 2/10 plus 41.3 times H. What humidity level is the apparent temperature at least 115 degrees? And then we use the x-intercept graphing method to solve it. Well, we want the apparent temperature, 90.2 plus 41.3 H. We want that to be at least 115 degrees, so greater than or equal to 115 degrees. Using the x-intercept method, we want to get that on one side. Let's move and subtract 115 from both sides, so we'll have negative 24.8 plus 41.3 H greater than or equal to 0. Now we'll graph this side of the inequality and find out what happens. Remember, we want greater than or equal to 0. We have transformed it to 41.3 x minus 24.8. We have transformed it to 41.3 x minus 24.8. We graph that. In our current window, it doesn't show much. So let's go to our window and let's change our x values to a much smaller range. We'll do -5 to 5 and then see if we have a graph that, and now we're looking for the x-intercept method. So we'll do second calc, and we want the 0. something to the left of that. To the left of it was 0. To the right, let's say 2. Enter. And let's take a guess of 1. And it's 0.60048,426. Here we have the results of our graph. At this point, the x-intercept point is 0.60048,426. 0 is our point. So the humidity level would be at 0.6005, or changing that to a percentage, basically 60% humidity will make 100 degrees Fahrenheit feel like 115 degrees Fahrenheit. Solving that same equation algebraically, we had 90.2 plus 41.3 H greater than or equal to 115. In this case, I'm going to subtract the 90.2 from both sides, get 41.3 H greater than or equal to 24.8. Divide by the 41.3 on both sides, and I'll find out H is greater than 0.6048,42615 on my calculator, changing that to percent. Again, the 60% humidity will result in 100 degrees Fahrenheit feeling like 115 degrees Fahrenheit. Sometimes we have what's known as a double inequality, resulting when two inequalities are connected by the word and or. Double inequalities can be solved either algebraically or graphically. Any operation performed on a double inequality must be performed on all three parts. And let's show an example how that would happen.